Now children, we move to the most important part of this heat engine, in which we basically measure, and this particular term is called efficiency, or we simply call as thermal efficiency of heat engine. And this is actually symbolized by letter eta. This is the symbol called eta. Yes, you know children, this symbol you have learned in class 10 also in one of the chapter called machine, okay, to measure the efficiency. Now even heat engine even has what? Efficiency. Even has what? Efficiency. But what is actually the efficiency of heat engine? So efficiency of heat engine is defined as, let me just write the definition. It is defined as the ratio, is defined as the what? Ratio of net work done by the engine. By the what? Net work done by the engine, okay, during one cycle. Let me just write down this way also. During one cycle to the heat taken from the source. Heat taken from the what? Source in one cycle. So I am using the word cycle because heat engine exactly our device, cyclic device. So there are number of cycles continuously repeated, okay, and due to that the work is continuously obtained. But in every cycle, okay, there is some amount of heat, okay, taken from the source, and in every cycle some amount of work, net work, is done by the engine, and that the ratio of net work done by the engine, okay, during one complete cycle and heat taken from the source in one cycle is actually measured by the ratio, and this ratio is called efficiency. So you just keep the statement, keep the statement that this statement, particular statement, say that efficiency is simply a ratio between the two similar quantity and has no unit. Yes, efficiency has no unit. It is a what number? Pure number. It is a pure number and has no unit. But when we write the efficiency of any heat engine, so we write in what percentage? We write in what percentage? But children, you know that there is no heat engine which has been ever designed which has efficiency 100%. There is no heat engine which has ever designed which has efficiency what? 100%. Now we come to the expression part of this heat engine. Now for that, let me follow this diagram, a working diagram of this heat engine, having source which is usually at temperature what? T1, then sink which is usually at temperature T2, where T2 is less than T1, and there is a main part of this heat engine that is called working substance. Okay. Now I consider that suppose this working substance, this particular working substance, take an amount of heat from the source, and that heat, suppose it taken by the working substance is say Q1. So I am writing that Q1 be the amount of what? The amount of heat taken from the source. From the source by what? Which substance? Working substance. By working what? Substance. So this working substance, the main part of this heat engine, takes say how much amount of heat? Say Q1 amount of heat from the source. And definitely this working substance gives some amount of heat to the sink. Okay, this working substance even gives some amount of heat to the sink, and that heat given to the sink I consider say Q2. How much? Q2. So I write down let Q2 be the amount of what? Amount of heat. Okay, this is the amount of what? Heat given to the sink. Given to the sink. So who is giving heat to the sink? By the working substance. But children, you know that this working substance will not give 100% heat to the sink. Okay, it will give only remaining part of heat to the sink by doing some amount of work by itself. And that amount of work which is done by the working substance is considered as W. So I am writing W be the what? W be the what? Work obtained. Okay, or work done by the what substance? Working substance. By the what substance? Working substance. Okay. Now, so if this is the quantity of work which is obtained or done by the working substance by giving Q2 amount heat to the sink, out of which Q1 amount of heat is taken from the source, okay, then definitely the net amount of heat that is absorbed by the substance can be calculated. So definitely this working substance absorbs net amount of heat, and that I write down the net amount of heat, the net amount of heat absorbed by the substance, absorbed by the what? Substance. And that net amount of heat absorbed by the substance is actually equals to Q1 minus what? Q2. Because Q1 is the total amount of heat that is supplied by the source. Okay, and Q2 is the amount of heat that is given to the sink. So how much amount of heat actually absorbed by the substance is given as Q1 minus what? Q2. Q1 minus what? Q2. And this Q1 minus Q2 amount of heat which absorbed by the substance has been actually converted into what? Work. Is actually converted into what? Work. So I don't know which is actually, okay, actually converted into work, which is actually converted into work. So I write down that W equals to Q1 minus Q2. So applying the first law of thermodynamics, as you know, for applying first law of thermodynamics, so heat can be converted into work. So this is the heat absorbed by the working substance, and this heat absorbed by the working substance is converted into work, which means it simply follows the law of conservation of energy, which means W equals to Q1 minus what? Q2. So this is for one complete cycle. See, as I said, in heat engine, there are number of cycles repeated continuously, and the work is continuously obtained. But for one complete cycle, the work done, or work which is obtained, or heat which is converted into work is given by W equals to Q1 minus Q2. But this is the relation which is written according to which law? First law of thermodynamics. First law of what? Thermodynamics. Now, with this work, I can calculate the what? Efficiency. Means we can write now the expression of efficiency of heat engine. So to write the expression of efficiency of heat engine, so we have already defined the efficiency of heat engine. It is defined as the ratio of net work done by the engine during one cycle to the heat taken from the source in one cycle. So as per the definition, efficiency means eta, and net work done by the engine one cycle means W by the net heat taken from the source in one cycle means how much heat is taken by the source from the source in one cycle, Q1. So eta equals to W by what? Q1. So eta equals to W by Q1 is the relation that measures the efficiency. But children, you can see the relation. W means what? Q1 minus what? Q2 divided by already Q1. So I'll split the LCM. So I write down Q1 by Q1 minus Q2 by what? Q1. So this Q1 cancel out means 1. So efficiency now is coming as 1 minus Q2 by what? Q1, sorry, this is Q2 by Q1. So look at the expression that measures the efficiency of what? Heat engine. And that is eta equals to 1 minus Q2 by what? Q1. But you know, Q2 is always less than Q1. See, the amount of heat which is given to the sink is only the remaining amount of heat that is absorbed by the working substance given to the sink, where Q1 is always the total amount of heat absorbed by the substance. That's why we have taken Q1 minus Q2. So if Q2 is less than Q1, then this quantity will be less than 1. And if this quantity is less than 1, then 1 minus that less than 1 quantity will be less than 1. And efficiency less than 1, children, means also called less than how much percent? 100%. So if I write this efficiency in 100%, means definitely this will be less than 100%. Even if you look at this expression of efficiency, children, that eta equals to 1 minus Q2 by Q1, this expression even makes the efficiency 1. Efficiency will be 1, or it will be unit, or it can be say 100%. But in order to make the efficiency 1 or 100%, Q2 must be equals to 0. Because if Q2 is 0, then how much it will be? Look at it. 1 minus 0 by Q1. So 1 minus 0 by anything is 0. That's why eta equals to 1 minus 0 is 1. So efficiency will be 1 or 100% only when Q2 is what? Q2 equals to what? 0. That means no heat is given out to the sink. No heat is given out to the sink. And this is not possible. So I am telling you again, children, this is not possible in practice. This is only the theoretical or ideal consideration. This means that the engine cannot convert all the heat taken from the source into work. All the heat taken from the source into work. That means there is no efficiency which is 100% efficient. Okay, that means the efficiency of heat engine is always less than what? 1. Okay, always less than 1 or how much percent? 100%. Similarly, I'll add another point from this expression of efficiency is that the expression of efficiency is also independent of the nature of the working substance. This expression of efficiency is also what? Independent. You need to write this point also. Also independent on the nature. On the nature of what substance? Working substance. So whatever nature the working substance may be, okay, it may be a real gas or ideal gas or any type of gases we take as a working substance, but the efficiency of the heat engine is completely independent of the working nature of what substance? Working substance. Whereas efficiency depends only on the amount of heat given to the sink and the amount of heat absorbed from the source. Okay. And children, for information, due to this second law of thermodynamics and the concept of heat engine, they are the engine which has been made, and these are practically we use in our day-to-day life, like steam engine. Yes, you have heard about steam engine. Okay. Now this steam engine is also works on the principle of heat engine. Okay. Now steam engine has efficiency. Just tell you about the efficiency of heat engine. Steam engine is only 10 to 17%. Similarly, we have petrol engine. Petrol engine is also works on the principle of heat engine, and this petrol engine also has efficiency how much? 30 to 40%, very less efficiency. And even we have a diesel engine. Even we have what engine? Diesel engine, and this diesel engine even has an efficiency which is not 100% but is how much? 50 to 60%. So these are the efficiency of different type of heat engine. From here you can clearly understand that there is no engine which has been ever designed which has 100% efficiency. Okay, so this is the detailed explanation of the efficiency of heat engine. Now in the next YouTube video you learn one of the ideal engine, heat engine, that is called Carnot heat engine. Okay, thank you so much.